Welcome. This video will show you how to quickly create a 3D printed strain-wave gear. Advantages of this implementation are that it is easy and inexpensive. In 1957, C.W. Musser invented and patented the harmonic drive. There are a few qualities that make it the best high-ratio gear available, but they are expensive, until now. Your requirements are an HDD closed-loop belt, as they are optimized for power transmission, unlike belts such as GT2, which are optimized for timing. HDD belts are inexpensive and easy to source. Bearings. Any common or custom bearing size would work, as its function is to push the belt to engage with the outside gear teeth. To model, first create a free Onshape account. Search in public documents for strain-wave gear. Then you'll find this one and the option to create a copy. There, you can see a completed model of one size, but you can quickly customize it, as each part is generated from minimal parameters that you enter. For example, for the gear, you enter the belt length, and if you'd like motor and hardware mount points. For the output gear, you have the same selections, but for this gear, also select the option Add 2 Teeth. Wave Generator. You select a common bearing, choose 2 or 4 bearings for now, and you get the width from the check and comments here. In the next tabs, we have the scripts that are creating the model, and finally, the assembly, where you can right-click the output gear on the left and select Animate, enter values, and play. How does it work? The bottom gear with the motor mount and the belt have the same 60 teeth. The top gear has 62 teeth. The center rotating shaft, the wave generator with bearings on the end, pushes the belt to engage with the teeth of both gears. The pushed belt forms a slightly elliptical shape. The narrow part of the ellipse is the red teeth of the belt overlapping with the gear teeth seen here, but the model doesn't have a flexible belt, and in reality isn't engaged with any of the gear teeth when not being pushed by the bearings, and the difference in teeth between the top and bottom gear powers the rotation. To export your model to print, go to the parts, for example the wave generator, where you can select the print checkbox. Then right-click the model name tab, select Export, and choose STL. This works in Chrome. Also check clearances when choosing connecting hardware. This is still a work in progress. My 3D printer and parts are ordered, but still a few weeks away. This model should be very close, but I haven't tested it, and the exact belt sizes could vary. This is a beginning point, and I would love to know how we can improve it. The high gear ratio allows for precision movement, but also, with slower movement, the torque would increase proportionally. The torque hasn't been tested, but with the widespread use of continuously variable transmissions in vehicles, high power transmission using a flexible metal belt is widespread. I look forward to your builds and ideas. Till next time, happy making.